Hello, my fabulous chemistry griffins. Mr. Milks here. Video number 6 for the atomic theory. Today we are going to get into isotopes and the average atomic mass. We got to do some math today. Math, oh my God, Mr. Milks, we got to do math. And on top of it, it's not even in our reference tables. So let's get into that I word, isotopes. I keep saying that I word. There's 3 of them we got to learn throughout the course of the year. These first 2 isotopes and ions we're getting into in this unit. An isotope is an atom with the same number of protons but different number of neutrons, giving it a different mass. And in our picture right here we see I have hydrogen atom with a mass of 1, I have a hydrogen atom with a mass of 2, and I have a hydrogen atom with a mass of 3. They're all hydrogen because they have 1 proton, but they have different masses because they have different numbers of neutrons. That's going to be a mess when I try to figure out how much these things weigh. Okay, I have a symbol and an atomic. The symbol's the same because the atomic number is the same, but the mass number changes for all isotopes. That is by definition what an isotope is. So this average atomic mass piece, the reason why this 12.011 is not 12.0 is because I had to get an average of all the different kinds of carbon that exist. The atomic mass of each tile represents the average mass of the natural occurring isotope of that element. And in this example, that would be carbon. Okay? In order to calculate this number, I need 2 things. I need the mass of each isotope, and I need to know how much of that isotope is around relative. So if I think of all the carbon atoms as 100%, well, 90% of them might be carbon 12, and only 10% of them carbon 14. That's why I don't just say the average is carbon 13. You see what I'm saying? We're going to have to get into that math. And here is the example of the math. This is the equation that you will follow. This is the equation that is not in your reference table. I take the weighted average, which means I take that percent abundance in specifically decimal form. Then I multiply that times the mass of the isotope specifically. Okay, so we're going to do an example on this next slide so you can see what I am talking about. This is the kind of math you need to be able to do this unit that isn't just adding and subtracting numbers. Okay, so I need to take 2 things. I'm going to use 1 color for the first one. I need to take the mass of this carbon, which is 12. I'm going to write it right there. And then I need to take the natural abundance of carbon. How many of these carbon is carbon 12? So that's this percentage. But I can't just multiply by a percent. I need to take that percent and bring it back into decimal form. Because remember, I did part over whole times 100. I need to divide by that 100, move that decimal. So now I get 0.9889. That is my natural abundance in decimal form. Okay, that's the first step. Second step, new color. Different mass. This time this carbon's 13. Here we go. 13 times this in decimal form. I got to move that over 2 times. I got 0.0111. I'm going to add these bad boys all together. When I get it set, I have 12 times 0.9889. Handy dandy calculator tells me that that is 12 times 0.9889. That is 11.8668. I'm going to add that to 13 times 0.0111. That's 0.1443. Add these things up. 11.8668 equals 12.0111. Look, that is the actual number that is on our reference table. We needed to practice this a bunch of times, so that's what we have practice pages for, okay, because this math is not the easiest, and we are just about done first with this video. So you need to complete these notes on pages 21 and 20 and 21. Please do your Google Classroom piece and hit done when you are done with that. Now we can do practice on pages 22 through 24, and we's outie. Plus we got another POGIL to do, so there we go. And we're done. Thanks for listening.